So I'm going to be presenting today a topic that's very sort of close to my heart, which is on analytics, but it's also about building applications because most of us here are developers. I'm a former developer, kind of having a background in computer science before I got started in analytics. And I actually am going to have a very special guest pop in and talk a little bit about ML and Google Cloud, and it'll be a surprise. I'll introduce him as I sort of go along. So let's get started. So that's me. I basically have spent most of my career doing analytics, and some of the opinions in here are my own, but that's and so definitely feel free to ask questions. Happy to chat afterwards. I head up analytics from the product marketing standpoint here at MongoDB. And again, it's something that's very, very dear to my heart. And so you'll hear a little bit about how I think about analytics and how that sort of plugs into the operational workload and building applications. So I'd like to start with sort of this premise that I think analytics is actually, having spent significant amount of time and most of my career in analytics is a little bit of an underachiever. Basically, if you look at the timeline, every about 10 years or so, we sort of reinvent the technologies that we're dealing with. And I started in analytics around 2000, and that was back when business intelligence and ad hoc reporting was really hot. Cognos was super exciting, and we were building dashboards. I worked for SAP and business objects after that, and in 2008, a lot of the analytics projects were not delivering. The data warehouses were sort of limping along, if you will. There's the whole business data warehouse, that reinvention that was going on, and then big data emerged, and I was part of that at Teradata and at Astrodata, and we had a Hadoop consultancy. And I think what we're seeing right about now, is that a lot of the big data projects are very, very big, and the problem is very big. And so there's a lot of frustration. If you've read Medium, there's a lot of articles about the frustrations of data scientists, how some of them are quitting their jobs. So there's sort of another revolution, if you will, brewing. And then if you look at kind of the last couple of years, AI has really emerged in the space as the next generation of intelligence, decision support, analytics. So I think as we try to reinvent the technologies, we're still really, really struggling to make analytics operational, actionable. That's not to say that it's not working, but there's pockets of success. But there's a lot of kind of boil the ocean projects that don't necessarily deliver. And by the time you sort of come up with your insight, basically the questions have changed, the data has become stale, there's a lot of issues with data wrangling. That's kind of, that set of problems is a known set of problems. So, I have a quote here from Forrester sort of talking about how about 75% of AI projects right now are sort of underwhelming and not realizing their return on investment. So, what are we going to do about this? On the other hand, as you saw if you were at the keynote just now, and there's a much more comprehensive set of slides of what customers are doing with databases like MongoDB. If you interact with anything pretty much in your day-to-day life, you can kind of tell, I don't have to convince you, that applications have changed the world. They've changed how we think about things, how we do things. These are some of the my favorite examples of our customers. And so really what I'm going to propose here is this an idea that when I was thinking through our approach to analytics and my role, and I was thinking through this talk, what I really wanted to talk about was how do you combine the operational and the analytical into a single set of operational, intelligent practices, right? And so what we've set out to do is to build an intelligent app. And I'm going to venture a guess that a lot of you are kind of already tasked with doing this if you're developers. Either you're trying to plug into the latest cloud services from from the cloud providers such as Google, or if you're trying to embed any kind of chatbot, functionality into your applications, like like some of the home services like Google Home or Amazon Alexa. Those are all kinds of things that you're maybe faced with in consumer space. And if you're not, perhaps you're trying to bring in some of the insight to make your application more intelligent, to give your users more insight about what's going on in the app. So what we set out to do was to have an example of such an application. And so this application is a combination of e-commerce app, which allows us to go shop online for products, pretty straightforward, that combines personalized product recommendations, which is a paradigm we're quite used to because we all shop on e-commerce sites. But actually, what does it actually take to implement that? And to bring that together, because recommendation engines typically are kind of a data scientist, project, if you will. And then what happens if you actually start to shop over some other delivery mechanism other than your web browser, right? And so shopping on a mobile device over an app was sort of the premise that we're going after. So what's an intelligent app? And we called this an intelligent app. Just to prove to you that I didn't sort of make this up entirely on my own, if you do a little bit of research, intelligent apps are emerging as kind of the next generation of applications. And there's some slides here about the set of predictions that Forrester talks about for the next few years. And they really talk about how intelligence, your edge, what algorithms you happen to use, and your kind of intelligent agents are becoming the next competitive edge that your organization is going to develop, no matter what industry that you're in. And there's some numbers here around the kind of spend that we're going to see, which is in the tens of billions of dollars in the next few years. So that's really something that folks are starting to pay attention to. And Forrester's not the only one who's talking about intelligent apps. So why is building an intelligent application a hard thing? Well, I think it's hard for many reasons, and data is actually one of the reasons, but another reason is sort of more organizational, or kind of how we think about these problems. And typically, to build an intelligent app, you need at least two sets of core personas. You need developers, obviously, who are going to be building the application. And they generally use live data, right? The applications are constantly generating this data. They often work in an agile methodology, kind of circular, cyclical fashion, right? They release functionality. They build it incrementally. And then the data scientists have a very different paradigm. And generally, it's very linear. So you start with an interesting question, and then you get some data, and then you prepare it, and you build a model, and you train it, and then you deploy it, and you generate insight. And I spent some time doing exactly that. And it's there's an incredible amount of pressure to ask the right question and to get the right answer. And so it's got this air of magic around it, right? How to get to the right insight. But then the issue is, once you get to kind of that finish line, how do you actually put it in production? And I think every organization has had some struggles and issues with how to do that. So the premise here is that really these are very different ways of thinking about problems, and these two personas are not very well positioned to sort of utilize each other's skills, but also take that insight that's very hard won, and then do something useful for the organization with it. So that's what we set out to do, and let's see if we've accomplished it. So to sort of start, we built the core e-commerce app. Our developer advocacy team kind of set out to do this as sort of the starting point. And we built a swag store. that lets you browse for your favorite MongoDB swag, and you can check out, put items in cart, look at orders, and we build it on Stitch and React. That's pretty much entirely it. So it's a serverless app that I'm going to demo to you today, and it has also cool, fun things like the restock notifications, and I believe there's another talk specifically about how to build an app like that using React and Stitch. So if you are interested in this sort of bit, go check that out later on this afternoon. Mike Lynn's delivering that. And for some of you who may not be super familiar with Stitch, just a little preamble on Stitch. It's MongoDB's serverless platform that really allows you to streamline development. And one of the really cool things about Stitch is that it allows you to simplify your code and plug into a lot of the services that are already out there in the ecosystem. And so that's primarily why I was interested in using Stitch for sort of a core kind of analytics and intelligence problem. So how do we build the swag store? Well, we built it using, again, React for the UI, and then everything else was built in Stitch. We built in the authentication using Google, and we built in some Twilio notifications. And then we used Stitch functions, rules and triggers, as well as service integrations to kind of enable the actual application. And then we utilize our flexible data model because it turns out we have all kinds of different products in our catalog, and we need to store users and products and orders and events, and we built it on Atlas on Google Cloud. So let's take a quick peek at that app, just to kind of prove to you that it is entirely real. I'm going to make this a little bit bigger. And we have products that we can browse. I can put a product in cart. My cart gets updated. I can check out. And really, the reality is it works just like any store. I have a profile associated with me. It's not a very interesting profile. So that's sort of the basics of the app. Now, so then we said that's great. It's an operational app. That's sort of, we're not inventing the wheel here. So what else can we do? So let's build in a recommendation engine. And building a recommendation engine is actually not a trivial thing, even though we're all familiar with how they work. So I actually said, hey, I'm not gonna reinvent how this is done. This is a hard problem. So what I'm interested in is I'm interested in an existing machine learning algorithm to do this. And we can hear in a moment about various ways to build recommendations engines, and if you're particularly interested in that, you can learn why it's a hard problem. But basically what I really wanted was to have the ability to sort of log into the store and have a personalized set of recommendations that are just for my user. And I wanted that to be a workload that's derived using machine learning. So we built that by using Google Cloud to basically utilize an existing algorithm that's written in TensorFlow, and Google Cloud ML would train and tune the model. And then we're going to ask Stitch to just plug in and grab the recommendations whenever the user logs in, and then populate that list of recommendations. The idea is that because MongoDB Atlas runs in Google Cloud, we can plug into the ML workloads on the same cloud, and effectively using Google Cloud endpoints, we're able to just serve up the recommendations in real time. Now, I didn't sort of invent this tutorial. I actually used an existing Google Cloud tutorial on how to do that. We made the data work for the demo purposes, but the idea is that you can literally, with a REST call, with with a simple HTTP request, you're able to go and grab this in real time, so that your data scientists can sort of have the data, populating on a recurring basis, use the algorithm that's already in existence to tune and train without sort of in a very streamlined fashion, without any magic, if you will, and kind of plug into that in a very native operational fashion. So kind of talking back to who does these things, right? So the developers in our developer advocacy team built the app. Typically, a data scientist would actually build the model and tune it. And in this case, we used the intelligence of our colleagues at Google who actually built this algorithm and this set of templates in this tutorial. And then typically a developer would sort of build the piping and the service integrations required to enable these two systems to work together. And generally, you would need somebody like a data engineer to actually enable the serving of the recommendations. And we'll talk about the kind of tools that are required to do that. So to talk about the recommendation piece, I have a special guest here from Google Cloud who actually built this tutorial. His name is Luqman Ramsey. And so I want to welcome him to the stage to talk about that specific piece. Thank you for being here.
Thank you, Jane. It's great to be here at MongoDB. So before I joined Google, which was about a year and a half ago, I was doing a series of startups here, acting as a CTO for startups in New York, and the last two I used MongoDB, as I mentioned to Jane, as the persistent store. So I'm a big fan of the technology and really excited to have the opportunity here to talk to you guys about the stuff that I do at Google, which is basically building architecture for machine learning. Both the actual training of the model part, but I think more importantly, and more interestingly in some ways, I've got a model trained in TensorFlow. Yeah, that's often not easy to do. But then how do I turn that into a production-ready system that doesn't just serve results based on the data set that I trained it on, but also takes data live from the real world and updates itself and stays up to date. So the tutorial that I built shows you how to do that on Google Cloud Platform. It actually takes, at least in the tutorial, data input from Google Analytics. So again, in this case with the e-commerce store, all you would really need is, as a data source, would be a Google Analytics account. It had to integrate Google Analytics with that site, and then ultimately that data could be fed through the cloud to serve as a source for the recommendations. Just by way of kind of giving you a very broad, very brief overview of the machine learning tools and infrastructure that we have in Google Cloud, we do have offerings across the spectrum from a complete set of APIs that allow you to get up and running to build machine learning applications very easily and quickly without having to build any machine learning models at all. Basically, all you have to do is write a REST call, and you can access APIs that do things like translation and vision and speech recognition and natural language processing. We have managed infrastructure to deploy or train models and deploy them for serving as well once you've trained them. So Cloud ML Engine, which you see in the middle there, is a great example of that. And then finally, of course, we make it possible for you, if you're more sophisticated, you have the necessary capabilities, you can train models in TensorFlow and then deploy them as production applications. But again, the gap between having a trained model and then deploying it in production it tends to be a large one, and there's I would say relatively less information about how to do that. So my goal in this tutorial was to sort of help fill that gap. I just want to mention one more thing before I go on and talk about the solution itself. Big new emphasis for Google in machine learning is what we call AutoML. That essentially kind of bridges that gap between the custom model development and the APIs. So it allows you to take your own data sets and train the APIs on your data. So if the APIs don't work for you for whatever reason, you have a set of images from your own catalogs or domain-specific language, say in a textual context, that the natural language API or the translation API is not doing well, then you can take your own data, train your version of the API, and that's what we call AutoML. AutoML takes care of the training for you. So you don't have to have the expertise necessary to train these very sophisticated translation or vision object detection APIs. And there are additional APIs coming, not just for vision and speech and these core perceptual kind of APIs, but also around recommendations and relational tables and things like that. So it's an interesting development to be aware of. The first set of those products is also already out in beta. Several of them are in alpha now. And at our next conference next month, you'll probably hear more about that. And again, one of the key takeaways from AutoML is that the AI itself is training the AI. So we have things like neural architecture search that basically automatically do the training, but also do the architecture of the model itself. And that blue line represents the performance of the AI trained models. The yellow line is the best-in-class human trained models. And what you can see is already the AI is doing better at AI than we are. I guess that's a kind of, you might think of that as a disturbing development, but that's the reality. So back to recommendations again. I'll turn the stage back over to Jane pretty quickly here. I just want to very quickly talk about the different approaches that you can take to recommendations. I'm not going to go into any great detail. I just want to point out that the one that's used in this solution is something called collaborative filtering. And the big distinction with that technique is that it's based on user behavior alone. Meaning there's no information present in the system about the things that you're recommending or the users for that matter. It's not like you need user profile information or some embedding or representation of the items that you're recommending. It's really just based on clicks, on user interactions with the system. User clicked on X. We're just observing what the user does and then generating recommendations based on that. So in the context of analytics, it really makes sense, right? Because that's the kind of data that you're collecting in analytics, right? User behavior. So I think that looking at architecture diagrams, looking at a real system is a great way to understand some of the complexity and the challenges that are associated with deploying production-ready ML systems. And so this is an example of that. You can see, as I said, that the Google Analytics data acts as the input to the system. So again, it's just the same data that any of your Google Analytics accounts are collecting. Really, it's just click data. It's page tracking data. So both timestamp, URL of the click, the user ID or client ID, which is an anonymous ID, and then we do a simple difference between this click and the next click to determine how long the user was on the page. And that amount of time represents sort of an implicit rating of that user for that page, right? So if they didn't click on it at all, that's a 0. And if they clicked on it but quickly navigated away from it, then spent very little time, that's a low rating. If they spent a lot of time on it, read the whole article, that's a high rating. Or for this could also be applied to an e-commerce context where if they didn't purchase it, it's a 0. If they did, it's a 1. That data is fed into BigQuery, which is a database that we have in Google Cloud. Again, very easy to also substitute MongoDB for that block. Really the database itself is not the important part here. But the training component is done again by a cloud machine learning engine based upon an algorithm called WALS, weighted alternating least squares, which is used to factorize the rating matrix. Again, if you're interested in knowing all the details about the solution, you can find it on the web. It's published under cloud.google.com. If you Google recommendations in TensorFlow, it probably will come up on the first page. There's also code in GitHub as well.
Yeah, and we'll have actually that on the last page to, and we'll distribute the decks afterwards, so you guys will definitely have all that.
And then, as Jane has already mentioned, basically the integration works as she said, the application server makes a REST API call to an endpoint essentially running on App Engine, which is fronted by Cloud Endpoints. It's essentially a simple REST call that, given a user ID, returns back the top K recommendations that you're looking for. And then just to wrap that up, again, not going to go into give you back your stage. The interesting things about this, some of the interesting things about this are that paradoxically, you have to have the entire data set that was originally used to train your model present at serving time, meaning when you're actually serving the recommendations, you have to have your entire data set of all of the history available. Can anybody think why that is the case? Well, in recommendations, it's very important not to recommend things that have already been purchased or viewed. Users will find that extremely not useful. Like, oh, great, you're recommending this stuff that I already bought, or these articles that I've already read. Yeah, thanks. So you actually have to filter those things out of the recommendations. And in order to do that, you have to have that data available somewhat in real time when you're performing the recommendations. So this is the kind of subtle thing that when you're just building a model to an ML model to do this, you're not going to be aware of. As a data scientist, as a machine learning engineer, you can build your model and like, yeah, it makes great recommendations. But then, when it comes time to productionalize this, the poor engineer who's responsible for this realizes that all the recommendations that are coming back are the same things that the user already viewed, because those tend to be highly rated in the recommendation algorithm. So you've got to filter those things out. So that's what's happening here. In the solution, I use basically an in-memory database technique. Again, in practice, if you're dealing with relatively small amount of data, say for the past 30 days, you can load all of that data into an in-memory database. And I use that to sort and filter the recommendations. So again, some of the subtleties that are involved. One more, I should say, is orchestration. So I think Jane mentioned Cloud Composer already. Basically, it's a new service. It's basically a managed service for Airflow, if you're familiar with that. Orchestration tends to be pretty important in applications like this, meaning it's not enough to just to train the model once, right? Now I want to retrain it. And I want to do that every half an hour or maybe once daily. It depends on how often or how up to date I want the model to be. Well, there's a series of steps that is involved in doing that, right? I've got to export my data, I've got to actually do the training, and then once I've got the new model, I've got to update the endpoint. And all of those things require steps in the cloud. And those steps are basically represented in a directed acyclic graph, DAG, and each step is executed one after the other. So this is a pretty simple DAG, right? It has 4 steps in it, each of which is executed after the other is complete. But again, a point that's often missed when you're just playing around with TensorFlow and training models, or when your data scientist produces a great machine learning model, is that when you deploy this thing and you've got to actually serve these things in real time and update that model in real time, then some amount of orchestration is almost always necessary. So again, there's the pointer to the code in TensorFlow in GitHub, and I will turn it back to you, Jane.
Yeah.
Thanks very much.
Yeah, thank you, Lukman. Yeah, so a couple of just quick points about how typically one does recommendation engines. So in the days that 5, 6, 8 years ago, when I did this for some of our customers, we would typically have a data scientist that actually knew something about the customer. So that would work for churn or recommendation models. So some of these techniques, the fact that you're actually not assuming anything about the customer, like their income or their gender or any of their preferences or where they live, is actually super powerful, because really the idea is that some of these factors, they're called latent factors, they're sort of hidden and they're already in the model. And that's what makes machine learning so powerful, right? In the old days, you literally would have to have these models that were very much based on features, right? And then you would select the features, you would train the model. It requires an incredible amount of resources, and you choose the wrong set of features, and your model doesn't work. So that's, even though what we're talking about sounds really complex, we've come such a long ways to actually make it simple and repeatable. And then the orchestration piece, again, typically requires a lot of moving parts and standing up servers to literally do this. But with cloud services, you can literally just plug things in and make them work. So those are the 2 quick points I wanted to make here. So basically, I took this kind of ready-made tutorial just to prove the point, and literally trained the model using sort of step-by-step instructions on Google Cloud ML and installed the code. And I ran the training script. Again, it's running TensorFlow underneath. And then we tuned the recommendation model. Again, in the old days, what you would have to do to tune the model would literally be select parameters, try again, try again, try again. Lots of human interaction. In this case, Cloud ML just does it for you. So, and then we generated the recommendation with Cloud endpoints, literally a set of product IDs, and we used Stitch to call out and to get those via HTTP request. So let's take a quick look at what that actually looks like. And so when here I'm logged in as a user, and when I sign in, let's just say as myself, this is the list of recommendations that I will get. And when I log out, and let's just say I sign in with my personal user, I'll get a different set. So literally this happens in real time, and we would update the model on a recurring basis to kind of retrain it. So another piece to our model was the chatbot piece. So we said, well, how about let's shop for products on a different interface. In this case, we chose Slack. And we used something called DialogFlow, which is also part of Google Cloud. And it allowed us to literally, without knowing anything about natural language processing, do some chatting and have the chatbot recommend products. So again, we use the same framework. We use our Swag store built on Stitch. We use the DialogFlow's kind of natural conversational UI and the webhooks. We used, and then we used Slack for the front end. And again, we had a lot of developers. We didn't have, this piece was sort of automated, right? So none of us here are data scientists. So that was pretty much given to us. And then, the kind of the data engineering part was stitching all these things together. And again, Stitch did a lot of it for us. So this is what the architecture quickly looks like. And again, really, we're serving these recommendations using service webhooks and Stitch. And we can know things such as, finding items, knowing what color they are, and doing the recommendations right from DialogFlow. And then we enabled the webhooks through Stitch. So let me just quickly do a demo of what that looks like. So here's my chatbot. I'm going to say hello to it once again, and it will respond. And hopefully we can see this. And so I can say, find a white jacket. And I'm actually given a jacket. Or find an umbrella. Well, that's because I misspelled umbrella. So this does work with.
I had a question on that. It doesn't understand that umbrella is umbrella.
Yeah. So the entity recognition. It's a good question. The entity recognition piece happens right here. So when we look for a product that's search.item, I'm actually. I specify the intent, which is I want to search for an item. I specify the entity, so I actually have the jacket as an entity and have the size, for example, defined as an entity. You can define things like color. But the idea is you don't need to do this completely from scratch, right? So this is a configuration-based API that we can just plug into for these sorts of products. And then for fulfillment, we're actually calling out to Stitch. If you can see this, this URL right here. And Stitch is what's actually handling the intent here of actually going back and getting the items from MongoDB database. And we're obviously doing some query result parsing to make sure that what we're getting is real, but basically we're going back to our Swag store database and grabbing these. So I'm happy to sort of answer question after this. I think I wanted to leave you with just a parting word about kind of what I hope this inspires for you to do that a lot of what developers and data scientists do together can really now be brought together in these intelligent apps. And I hope that you can use some of these paradigms and some of the services that are frankly available now for us as developers to go build intelligent apps in your organizations. And I just wanted to quickly give credits to the folks that helped develop this, our developer advocacy team, and also Jesse from our product marketing team, who's not here. But also Stitch is out there. The Google Cloud ML tutorials are out there, and so is DialogFlow. I'm happy to take questions afterwards, and thank you very much.